Hi, welcome everyone. Today I'm going to teach you how to use Pop CLI to develop an Ink smart contract. And for that, I already have Pop CLI downloaded, so you can see here if I do pop help, you get all the commands. So specifically for today, we're going to use the pop new contract command. What this will do, it'll load up an interactive mode and you'll be able to select the different templates. So as you can see, there's PSP, ERC templates. We're going to start with just like a basic Hello World template. It's the Flipper template. And I'm going to call it Flipper. And you can see it's already created. If I open it up inside of my editor, we can take a look at this Ink Smart contract. This is essentially the most basic Ink Smart contract you can have. So those of you who are already familiar with Ink Smart contracts, this should be very simple and straightforward. Those of you who are not, you can see that this is Rust, right? Ink is like essentially Rust with macros and macros that help one with smart contract development. So you can see we have a storage here. This is the storage for the smart contract. It's defined as a struct. And for this one, it's a value of type Boolean. So value can either be true or false. And here in the implementation of the actual smart contract, every Ink smart contract needs to have a constructor. This one has two. And this constructor, it's new, it's called new, and accepts an argument for the initial value of the state, right, whether it's true or false. And then this one here, it doesn't accept any argument. So if we just instantiate the contract without specifying the constructor, it'll just use the default properties for Boolean. This Ink Smart Contract Flipper has two messages. You can think of them as functions, right? One is flip, and what it'll do, it'll take the value that's inside of storage and it will flip it. And it'll store it inside of state, inside of storage, right? So if the value inside of storage is true, it'll flip it to false, store it as false. The other function here is get. So it simply reads the value that's in storage and returns it. All right, so let's say that this was an Ink Smart contract that we were developing, we're happy with it, and we now want to deploy it to a blockchain, right, to actually really test it out. So we can do that with Pop CLI. There's a command called pop up contract. And this command accepts a constructor argument. So I can say constructor, and I can say new. We're going to call the new constructor function that we have. And it accepts initial value. I'm going to initialize to true. And then by default, if I hit return, it'll actually sign this transaction using the Alice account, the Alice development account, right? So those of you who are new to development Polkadot, there's Alice, Bob, Charlie. These are all development accounts. So we're going to use the development account. That's fine. But if you wanted to, you could input a specific address here, a specific account to sign this transaction with, right? The other thing that if I hit return right now, notice I didn't specify a blockchain to connect to in order to deploy the smart contract to, right? Like, where is this smart contract going to be deployed to if I just hit return? Well, by default, Pop CLI will spin up a blockchain node on your computer, a substrate blockchain node that has pallet contracts. Pallet contracts has to do with substrate framework. It's what runs Ink Smart contracts, okay? So Pop CLI will spin that up for you. It'll be running on port 9944, and it'll deploy to that port, okay, to that node. So I just hit return. You can see it's building the contract, and it's building it in release mode. So it's going to be like an optimized build. And I don't know if you noticed, it happened really quick there on the left-hand side on the Navigation Explorer section. You have this target folder. So when this is building, the way that Ink works is that we're going to get a WASM output, so WebAssembly, right? So you can actually see it should be here by now, right there. So that's actually our smart contract, right? That's flipper.wasm. That's our smart contract in WASM form. This is what the node will run. This is what Pallet Contracts runs. This WASM adheres to that API, right? So it's still being built out. We're going to get another file here that our metadata. Oh, there it is. Okay, so you can see we have our WASM. We have flipper.json, which is our metadata. Like I could show you that. There it is. It's all the metadata for the contract. And then we have the flipper.contract, which is actually the metadata and the WASM together, okay? And it looks like your contract artifacts are ready. You can find them in this path, which is the path I just showed you. No endpoint was specified, that's correct. Would you like to start a local node in the background? Well, thank you, yes, I would like to, yes. So it's gonna spin up a node on this machine, smart contract compatible node. And there it is, that was pretty fast. So we can actually see the node. I'm gonna copy this URL, let's pull that up. Open up my browser window, drop it in there, and there's the node. Okay, so you can see that a lot of useful information. The most recent block is block number 1. It's a brand new node, right? 1 block. The other thing that you see here are events. These are events from the node, right? These are node events. And what's interesting is that you can see here contracts.code stored. So this means that the contract got uploaded. There's the code hash. Another one that's nice here is instantiated. So not only did the contract get uploaded to this blockchain, but it also got instantiated, right? And it got instantiated by Alice, like I mentioned before. And there's a contract address there if I wanted to copy it, right? Another place where you'll see the contract address is in the output here. The contract address is, boom, copy it, okay? So we could hop over here, developer contracts, and I already pre-appended this here, but you're gonna have to drop it in. So you're gonna have to go add an existing contract, drop the address, enter the name here, and select the metadata, and it'll show up, right? So this is just a UI, a different way that you can see the contract, interact with the contract. There's also another UI that you can use that I use quite often, probably more often than this one here, is ui.use.inc. So I already have it pre-configured here as well. You can see there's Alice, the account. I can call this contract with different accounts. So that's visually pleasing. And then different methods available on the contract. Okay, so flip and get, and you get some nice info here, right? So the other place that you can use to develop and interact with a contract, let's say, is pop CLI. So with pop CLI, I can just like copy the address, and I can say, hey, pop call contract, and I can say contract, specify the address, and let's check the contract state, right? Remember that get method, the get message? So I can say message get, right? So I'm going to call the get message on that Inc smart contract. And there's a result. So it's true. The result is true, which is correct. Remember, we instantiated it with true. So the current state of that contract is true. Notice it says your call has not been executed, which is true. I did, how do you say, I called the contract without using the execute flag because it just so happens that the get method is just reading the state, right? So we can check the contract state without submitting a transaction, without paying gas fee. You could also submit a transaction to read the contract state, but it's not necessarily with Substrate. You can just connect to the RPC node, read the state, and get it back, right? And that's what this did. Now, let's say I wanted to call flip, which is, it mutates the state, right? In that case, I want to say -- execute, and it's going to execute the transaction. If I don't include that flag, it'll do a dry run, which is useful sometimes for like making sure that the function works. But I actually want to submit a transaction and mutate the state. So you can see how fast that was. That's output from the node itself. Event balances, event contract was called, right? Some useful information of who the caller was, what the contract was, and so on. Fee was paid. So it got called successfully. If we wanted to, we could go back to our previous method here, get, and check the state again, and there it is, it's false. Okay? So that's it for today. If you want to see like a written version of what I just discussed, there's onpop.io, and onpop.io has docs, learn.onpop.io, and you just hover to the smart contract session, and on the left-hand side, there's guides. So you can see there's create new contract, build your contract, and deploying your contract locally, as well as interacting with your contract. All right. So Thank you very much, everybody. Happy hacking.